Hello, welcome to another mathematics lesson. My name is Kingsley Linus. In today's mathematics lesson, we'll be looking at the topic subtraction of numbers in base 2 under the theme basic operations. By the end of this lesson, you should be able to subtract binary numbers. Now, I expect that before this video, you must have seen the lesson on addition of binary numbers. Now, let's move on in today's lesson. Now, just like a recap to what we've learned before now, number bases are like foundational blocks we use when we count, calculate, or measure things. We also mentioned the fact that the decimal number system is the most common number system. Apart from the decimal number system, there are other number systems. For example, the binary number system. The binary number system is a number system where we count in groups of 2. And in the binary number system, we have just 2 digits, 1 and 0. Now, this number system has been found very helpful and relevant in the world of computing because it provides an easy way of storing information. Now, let's go on to focus on what today's lesson is about: subtraction of binary numbers. Before now, we learned that we can carry out basic operations in binary. When we talk about basic operations, we are referring to addition, subtraction, multiplication, and division. Subtraction in binary is done in a similar manner to what we have in decimal. Now we have rules. Let's look at what these rules are. The table here shows the rules we follow, or the basic facts when we do subtraction of binary numbers. When we have 0 minus 0, it gives us 0. And when we have 0 minus 1, what we do is to go to the next significant bit and borrow a 1. And when we borrow a 1, we then have 1, 0. And 1, 0 minus 1 gives us 1. This explanation will get clearer while we go into the lesson. When we have 1 minus 0, it gives us 1. And 1 minus 1 gives us 0 in the binary number system. Now, this is more like a further illustration to what I just said, talking about the rules in subtracting binary numbers. 0 minus 0 gives us 0. 1 minus 1 gives us 0. And 1 minus 0 gives us 1. Now, in the case of 0 minus 1, what we do is to borrow 1. You can see we have a 1 here, so we can take that 1 over, and what it becomes is 1, 0. So 1, 0 minus 1 gives us 0, 1, which is 1. Now, the equivalent of 1, 0 in decimal is 2, and then 1 is 1. You realize that 2 minus 1 gives us 1. So that validates our answer. Now, let's see how these rules can be applied. We have the number 1, 0, 0 minus 1, 0. Now we start 0, 0 minus 0 gives us 0. 0 minus 1, we won't have an answer. What we need to do is to go to the next significant bit, which is this, and then we borrow the 1. And when we add it here, it becomes 1, 0. 1, 0 minus 1, and then we bring down 0 because we have nothing left in this column. Now, if we translate 1, 0, 0 in binary, you will have 4 in decimal, and 1, 0 in binary would give you 2 decimal. Now, 4 minus 2 gives us 2, and the equivalent of 2 in decimal is 1, 0 in the binary. We also have another practice question here. 1, 0, 0 minus 1. 0 minus 1 cannot go. So we go to the next significant bit. The next significant bit is also empty. We have a 0 there. So we go to the next, and then we borrow 1 from this point. When that 1 gets to this place, it becomes 1, 0. Now, but that's not our destination. We need to move. So we borrow 1 again to this point, and then it makes this place to become 1, 0. Now, but this place will not be left as 0. It will be left as 1, because the one we borrowed from this point, when it got to this point, it became twice as valuable as it was from where it came from. So we have 1, 0 here. 1, 0 minus 1 gives us 1. And then we are left with a 1 here. 1 minus nothing gives us 1. So when we do our conversion to decimal, we have 4 minus 1, and 4 minus 1 gives us 3. The value of 3 in binary is 0, 1, 1 or 1, 1. Now, let's look at some examples. I believe you know that your ability to subtract numbers or to learn how to subtract numbers will be dependent on how well you practice these exercises. The instruction here says subtract 1001 from 10110. Now, it is important to note that you have to subtract the smaller number from the bigger number. And most times, by the presentation of the question, the smaller number comes first. So you don't get to mix them up. If you have a proper arrangement, you are certain to have accurate answers. Now, we have set out our numbers like we have here. We can go ahead to do our subtraction. 0 minus 1. Of course, you know, whenever we have 0 minus 1, we can't have an answer. So we go to the next significant bit, and then we borrow a 1. So we have 1, 0 minus 1. That gives us 1. Now, what we are left with here is 0. So 0 minus 0 gives us 0. And then 1 minus 0 gives us 1. 0 minus 1, we have that situation again. So we borrow 1 from the next significant bit. So we have 1, 0 minus 1. That gives us 1. Now we are left with nothing here. So this is our answer. Now, just for a check, if we convert this number to decimal, we would have 22. And when we convert this to decimal, we have 9. 22 minus 9 gives us 13. Now, looking at our answer, the value of this 1 is 1. And this one here represents 4, while this one represents 8. When we put all this together, we would have 13. So this is our answer to this example. Now, let's look at some more examples. Subtract 1, 0 from 1, 1 and subtract 1, 0, 0 from 1, 1, 0, 1. So we set out our numbers and then we go ahead to do our subtractions. 1 minus 0 gives us 1. 1 minus 1 gives us 0. And 1 minus nothing gives us 1. Now, to the second example, after setting out our numbers properly, very important, we can go ahead to do our subtraction. 1 minus 0 gives us 1. 0 minus 0 gives us 0. And 1 minus 1 gives us 0. Then lastly, 1 minus nothing gives us 1. Now, let's see some more examples. These examples have a little twist, but what we are meant to achieve here is still subtraction of binary numbers. Question 3 says x plus 101 equal to 110. And then question 4 says if x plus 1011 equal to 1100, we are expected to find x in both questions. Now, x plus 101 is equivalent to 110. To find the value of x, we can take 101 from 110. Now we properly arrange our numbers like we have here, and we can go ahead to do our subtraction. 0 minus 1, we won't have an answer, so we go to the next significant bit, which is 1. We add 1 to 0, we have 1, 0. So 1, 0 minus 1 gives us 1. Now you realize that we have nothing left here. So nothing minus 0 is nothing. And then 1 minus 1 is also 0, which is nothing. So our answer to this question, or the value of x in this question, is 1 base 2. Now, moving on to the next example, we have a similar situation, x plus 111 equal to 1100. Now, to find the value of x, we take 111 from 1100. Now we set out our numbers and then we go ahead to do our subtraction. 0 minus 1, we won't have an answer, so we go to the next significant bit. The next significant bit is 0. So we move on to the next significant bit, which is 1. Then we borrow our 1 from this point. When we get to this point, it becomes 1, 0. And then we move again from this point to this point, and it becomes 1, 0. So we have 1, 0 here. Don't forget that the remaining value we have here would be just 1. Now, 1, 0 minus 1 gives us 1. 1 minus 1 gives us 0. And then, having borrowed from this place, it became 0. So, 0 minus 1, we won't have an answer. So, we go to the next significant bit, which is 1, and we borrow the 1. So, we have 1, 0 here. So, 1, 0 minus 1 gives us 1. And this is the value of x in this problem. Now, I believe with these examples, it is quite clear to you on how to carry out subtraction of binary numbers. Let's try out some exercises. At this point, do well to pause the video and try out these exercises. I'm sure you're done. The correct answer to question 1 is 1, 0, 1, 0, 1, 0. And the correct answer to question 2 is 1, 1, 0, 0, 0, 0. And lastly, the correct answer to question 3 is 1, 0, 0. If these were your answers, you are correct. And please note that all these answers are in base 2. This is where we come to the end of this lesson. But before we go, let's look at all we've learned in a summary. First, we learned that number bases are like the foundation blocks we use daily when we count, measure, or calculate things. Secondly, we learned that apart from the decimal number system, there are other number systems. For example, the binary number system, and so on. Furthermore, we learned that counting in a group of 2s is the same as counting in base 2. This system of counting has been found very useful in computing and its application. Also, we learned that when subtracting binary numbers, we must keep in mind that counting is done in groups of 2, and we must keep to the rules of subtraction in base 2. And lastly, we saw the rules of subtraction, where 0 minus 0 gives us 0, 1 minus 1 gives us 0, 1 minus 0 gives us 1, and 0 minus 1, we move to the next significant bit to borrow a 1 to add to a 0 to become 1, 0, and then we subtract, and then our result will be 1. Now, I have some test questions for you to try, just to see how well you understood this lesson. Question 1. Evaluate 1, 1, 0, 0, 1, 1, 1, 0, 1 minus 1, 0, 0, 1, 1, 1, 1, 1, all in base 2. The correct answer to this question is option B. Question 2 says, evaluate 1, 1, 0, 0, 1, 0, 1, 1 minus 1, 0, 1, 0, 1, 1, 0, all in base 2. The correct answer to this question is option D. Thank you for your time. Till we meet again in another mathematics lesson. Bye-bye.